This is the body fluid and compartment tutorials presented by the SchrDbb. We reference Color Laws of Physiology by Agamemnon de Bospoulos and Stefan Bernard. Hello, in this tutorial we're going to see the body fluid components. So now we need to know that what maintains the body fluid component is the intake of water and the outflow of water, the output of water. So now the intake of water is going to occur via the water oxidation, which is going to have a 0.2 liters of water. So at first point, before having all this, you need to know that 2.5 liters of water absorbed a day and 2.5 liters of water are outputted a day. So that is going to maintain a constant amount of water and make sure that this pivot, this system is going to be in equilibrium. So now if you have the intake which is much more than the outtake, so you see that there are going to be an accumulation of fluid, so you're going to descend here. So if you have intake much more than this other one, you're going to descend and you're going to have accumulation of fluid. So there are certain processes which are going to occur when there is accumulation of fluid. Again, if you have the output much more than the intake, so you're going to have the raising on this other side, so you're going to have a deficit of fluid. So now let's visualize now what is going to happen. What are the different methods by which water is being inputted inside the body? So you have water oxidation, which corresponds to 0.3 liters of water in a day. We have food, which corresponds to 0.9 liters, so 1 liters of water. And we have beverages and water when we are drinking, which corresponds to 1.3 liters of water a day. So the water which is being the water which is being excreted or outputted depend on the water excreted in feces. The water excreted in feces is 0.1 liter a day. So the water which make up our feces is 0.1 liter all through the day. The water which is going to be excreted via respiration and perspiration. Perspiration is another name for sweating. So water which is excreted via respiration and perspiration or sweating is going to be 0.9 liter to 1 liter a day. And the water which is being secreted in urine is going to be 1.5 liter a day. A simple method to cram is that the values, each values are closer to the corresponding value on this other side. The food here is perspiration and respiration. This other one here, which is via oxidation, is close to the excreted in feces, and this other one, beverages, is close to urine. So now, depending on which is higher than the other, you're going to have either a deficit or an excess. So now let's visualize the body water contents. So now, in order to visualize the body water contents, so the body water contents can vary depending on infants toward old age. In infants, the water content is very large, and this is a fraction of the total body water to body weight with respect to body weight. So now with respect to body weight here, the total body fraction is going to be 75% here. So here we are going to have 0.46 to 0.75 liters per kilogram of body weight. So you have 0.546 to 0.75 liters of water per kilogram of body weight of the body weight. So inside the baby you're going to have 0.5 liters of water per kilogram of body weight. Inside men, you're going to have young men, you're going to have 0.664 kilograms of water per kilogram of body weight. In women, you see that it is reduced. It is reduced in women because women have much more adipose tissue. Now the more they are becoming old, the water level are going to decrease because the tissues are becoming more elastic and they are aging. This is why you have wrinkleness of tissue in older people. So now it is required for you to know that the tissues of the body are divided into two main parts. We have fat and we have other tissues like proteins. So now in the total body water, you need to know that water in the total body, you have 60% in a normal person, there's 60% of total body water inside the human body. 60% of water make up the total human body. But now there will be 70% of water inside the part of the body which is only made up of proteins, the part of body which is not made up of fat. So in the total body you have 60% of water, but inside the part of the body which is not made up of fat, you have 70% of water. So now the part of the body which is not made up of fat, it is called the lean body mass. The part of the body which is not made up of fat is called the lean body mass, while the part of the body which is made up of fat is going to be called the fat mass. So now we realize that there is 70% of water which is going to form the lean body mass. So 70% of water is going to be present inside the lean body mass, while the rest, fat mass, is going to be formed by the rest. So we know that the total body, so you can say that in order to calculate the fat mass and lean body mass, you can say that the total body weight will be equal to the fat mass plus the lean body mass. So we already have the total body mass here. So let's say the total body mass is 70 kilogram. So 70 kilogram is going to be fat mass plus the lean body mass. Now we know that the lean body mass, so we know that 70% of water is going to make up the total 70% of water is making up the lean body mass. So now you know that the total body water will be only much more present. You can see here fat only has a minimal amount of body water, while the total body water is mainly made a constituent of the lean body mass. So you can see 70% of total body water, 70% of lean body mass will be equal to 60% of total body water, and from here that you can calculate the lean body mass. So lean body mass will be equal to 60 all over 70 times total body weight, total body mass. So this is going to give you a certain value, and from there you can calculate the fat mass, an approximate value of this fat mass. So now we need to know that the total body water has different compartments involved in total body water. We have the extracellular compartment and we have the intracellular compartment. The intracellular compartment is 2/3 of the total body water. So intracellular compartment of the body is 2/3 of the total body water, while the extracellular compartment of the body is 1/3 of the total body water. So inside extracellular fluid, you have 1/3 of total body water, and the intracellular fluid has 2/3 of total body water. The intracellular fluid is maintained by potassium ion inside the cells, while extracellular fluid is mainly maintained by the sodium ion outside the cells. So now extracellular fluid is divided into two main parts. We have the blood vessels and we have this interstitial fluid. Interstitial fluid can comprise of this transcellular fluid here. So now blood vessels made up 7 all over 10. So 7/10 of the extracellular fluid is going to give you the volume of plasma water. So 7/10 of the extracellular fluid is going to give you the volume of plasma water, or you can also say to feed. So it's either 7/10 or 1/4. So 7/10 of total body of extracellular fluid, 7/10 of extracellular fluid, or 1/4 of extracellular fluid is going to give you the plasma water level. Why the interstitial fluid level is either no. So for the plasma water, it is instead 3/10 of the extracellular fluid, or 1/4 of extracellular fluid is going to give you the plasma water level. Now the interstitial fluid level is going to be either 7/10 of the extracellular fluid, or it's going to be 3/4 of the extracellular fluid level to give you the interstitial water. So this interstitial water is also going to comprise of the transcellular water here. So now let's say now you want to measure, if you want to measure the different body fluid compartments, let's say you want to measure the different body fluid compartment, you need to know that Evans blue dye is going to be used to measure the plasma concentration of water. This is because the Evans blue dye is only diffusible, is not diffusible to other compartments. Since it's not diffusible to other compartments, let's say you have an initial concentration of Evans blue, and after a certain period of time that you have injected Evans blue into the blood vessels of the body, you are going to have a new concentration of Evans blue. So in order to calculate the plasma volume, you're just going to say that initial concentration equals to final concentration, and then after saying initial concentration equals to final concentration, you're going to say that the initial for Evans, we are going to say initial number of moles of Evans blue is equal to final number of moles of Evans blue. So number of moles is going to molarity times volume. So the molarity, initial number of mole of Evans blue is going to be the molarity of Evans blue that you now calculate in the blood vessel times the plasma volume of water that you are trying to calculate. So the plasma volume of water is going to be equal to initial concentration of Evans blue divided by the volume of divided by the concentration of Evans blue that you are going to find now in blood when it's completely diffused. So now you have indicator. When you want to find the extracellular fluid volume, you instead use inulin. So Evans blue is used here, and you can have also some other molecules, but here you mostly use inulin. You can also use sucrose. You can also use sodium ion at times. So inulin can diffuse through the extracellular fluid or through the extracellular compartment. So extracellular fluid compartment. So now when the final concentration is going to have the volume as being extracellular fluid, so here the value for extracellular fluid measurement will be equals to the volume of extracellular fluid will be equals to the initial number of mole of inulin divided by the molarity of inulin when you calculate, when you find when it has completely diffused after a certain period of time. And lastly, antipyrine will be used is going to be used to calculate total body water. So you can first calculate extracellular fluid water by using inulin, and then to calculate intracellular fluid water, you are going to say total body water minus extracellular fluid water by using the antipyrine, because antipyrine is going to diffuse all through the body, all through the different compartments. So apart from antipyrine, you can use again you can use a water molecule which has a hydrogen ion with three protons and 2 protons. So we have dihydrogenated water molecule, and we have a hydrogenated water molecule. All these are going to be involved with the measurement of the total body water, and thus the measurement of intracellular fluid. So now let's visualize how the salt level of each compartment are going to be regulated. So now if you have so regulation of salt and water balance, so water deficit, in case that you have a water deficit inside the body, you realize that the water deficit, you are going to, when you have a water deficit, is going to increase the osmolality and is going to reduce the arterial pressure. The increase in osmolarity and reduction in arterial pressure are going to cause the secretion of ADH from the posterior pituitary gland. So you have also the test is going to be activated. So when ADH is going to be secreted, so this is going to cause reabsorption of water from the kidneys, and thus the urine level is going to decrease. While if you have an excess water, the osmolarity is going to decrease. Since the osmolarity is going to decrease, it's going to inhibit ADH production, so no reabsorption of water, less reabsorption of water, and so much urine is produced. So this is in case of water excess and deficit. Now let's visualize in a case where you have a salt excess and deficit. In case of salt excess, you see that in case of salt deficit, you see that the osmolality of the blood is going to be reduced. Since the osmolality of the blood is going to be reduced, you are going to have inhibition of ADH. So in the first point in time when you have a salt deficit, you are going to have water diuresis. So in case of salt deficit, you're going to have first a water diuresis. So this is going to reduce the plasma volume and blood pressure. After the reduction of plasma volume and blood pressure, you are going to have now the activation of the renin system. So now the renin system is going to activate again angiotensin, which are going to increase the blood pressure by vasoconstriction. It's going to affect also thirst. So initially when you have a salt deficit, you do not yet have thirst. The thirst, you first have an inhibition of thirst when you have a salt deficit due to a reduction of osmolarity. It is now when you have lost your water due to diuresis, formation of water inside the bladder, that you have now increased sensation of thirst due to renin activation here and the angiotensin 2. So now angiotensin 2 is also going to activate now the aldosterone, which is going to cause now the reabsorption of sodium ion, because salt deficit, they are trying to increase the sodium ion reabsorption. So now coming to the salt excess, you see that osmolarity is high. So in this case, you're going to have AGA secretion. So the plasma and the blood pressure level are going to increase with the test. So all these are going to increase the blood pressure. So increase in blood pressure is going to deactivate the renin system. So angiotensin is not going to be secreted. And also increase in blood pressure is going to activate the arterial pressure. It's going to make the arterial pressure to increase. As the arterial pressure is going to increase, it's going to make the arterial cells at the level of the heart to secrete ANP, arterial natriuretic peptide, which are going to cause the aldosterone are going to inhibit the secretion of aldosterone, and are also going to cause the reabsorption of sodium ion to reduce. This is why sodium ion is going to be much more released in urine. So now the last part of this body fluid compartment tutorial will be a part based on the diuretics. So now let's visualize the different diuretics now in order to maintain the body fluid compartment and cause the embraces. So diuretics are any chemicals which are used in order to cause much more water to flow out of the body. So the first diuretic, which is not usually used as diuretics, is carbonic anhydrase inhibitor. So if you inhibit carbonic anhydrase, then you cannot have the conversion of carbon dioxide to hydrogen, carbon dioxide plus water to hydrogen ion and hydrogen carbonate. So since you cannot have the conversion to hydrogen ion and hydrogen carbonate, then you see that the sodium ion, hydrogen ion with simple are not going to work. So so you are going to have accumulation of hydrogen carbonate and sodium ion inside the lumen, and which are going to flow outside of the body. So it's one of the diuretics. Another diuretic can be the loop diuretics. Example, the furosemide. Example here is acetazolamide. So here the furosemide are going to act on the channels that you have seen initially: sodium ion, potassium ion, 2 chloride ion, sodium ion, potassium ion, 2 chloride ion, syn-porter. So as they are going to act here, they are going to inhibit this syn-porter. So the sodium ion, the 2 chloride and the potassium ion all are going to be found inside urine. Another one is the thiazide diuretics. The thiazide diuretics are acting at the level of the sodium ion, chloride ion, syn-porter. So we also have an aldosterone antagonist, and this one is said to be a potassium ion sparing. So if you want to have a diuretics, if you want to have a diuretics which is not going to change the level of the intracellular fluid, you know that intracellular fluid of the body, intracellular compartment, is mainly maintained by the potassium ion. So if you don't want to change the intracellular compartment, you want to reduce the body fluid, but you don't want the intracellular compartment of the body to change, you can use the aldosterone antagonist. So aldosterone antagonists are going to prevent the functioning of the sodium ion, potassium ion ATPase. So this is going to prevent the secretion of potassium ion into the intracellular fluid and then out inside the lumen. So the spironolactones are very used to maintain the potassium ion concentration of blood, and thus maintaining the potassium concentration of the intracellular fluid. So this maintains the intracellular fluid volume. So now let's visualize now this other part here. We have aldosterone antagonists. So they are going to aldosterone antagonists. Here they are only blocking. So they are only blocking the activity of the sodium ion channels. So they are going to block the activity of sodium ion channels indirectly. So now we also have the amylorides here, which are going to block now the activity of the sodium ion channels directly. So they block activity of sodium ion indirectly by affecting the sodium ion, potassium ion ATPase, and here they block directly by affecting the sodium ion channels. So now these are the different mechanisms which can occur when you have salt disturbance with fluid disturbance. Here, in case here the osmolarity of the extracellular fluid is similar to osmolarity of intracellular fluid, this is normal state. So now in case where you have isosmotic volume deficit, so here you have a reduced in volume, but here there is the volume here is smaller. You see that there is no flow of blood because there is no constriction gradient. But in case here where you have a hyperosmolarity here with a reduced volume, with a hyperosmolarity here, you see that volume of blood is going to flow to increase here, but there is no hypertension in this case. So there is going to be reduction in intracellular fluid. Yeah, in case where you have a salt deficit, you see the salt deficit. You can have salt deficit by vomiting, diarrhea, perspiration, and low serum deficit. So when you have all this, you realize that the water is now going to enter into intracellular fluid due to more concentration here than here. When you have excess water but the isosmotic, there is no flow of water. But here when you have excess water with here is hyposmolar, this is hyperosmolar, you have the flow of water inside the cell. And lastly, when here is hyperosmolar and here is hyposmolar, you are going to have flow of water inside the extracellular fluid, which is going to cause you a state of hypertension. So from here we've seen basically the main things which are involved now inside body fluid compartment, and we say thanks for kind attention. Please don't forget to like and subscribe for Science View Makers. Thank you.